Elon Musk stood before a massive screen displaying a glowing red orb. The audience leaned forward, captivated by the familiar yet alien world on the display. A faint hum of machinery echoed in the vast presentation hall. Musk's eyes scanned the crowd with a mix of excitement and determination. "This," he began, pointing at the screen, "is where humanity's next great chapter will be written." The image shifted, revealing a sprawling network of structures under a transparent dome. It was not just a colony, it was a city. Every building shimmered with a metallic sheen, designed to withstand Mars' harsh dust storms. Solar arrays stretched like golden fields across the crimson landscape. In the center, a towering spire rose, crowned with a bright beacon. Musk explained that this was the heart of the Mars city, its command and life support hub. Engineers in the front row scribbled notes as if every word carried the weight of history. The prototype model shown on the screen was the result of years of secret development. SpaceX had been quietly working with scientists, architects, and even artists to bring the vision to life. The city was designed to support 1,000 people in its initial phase. Expandable modules would allow the population to grow over decades. Life support systems were tucked beneath the surface, shielded from cosmic radiation. Greenhouses, illuminated by artificial sunlight, promised year-round crop production. Massive water tanks glistened under the protective layers of the habitat dome. Musk detailed the city's power system, which combined solar energy with compact nuclear reactors. The dual power source ensured redundancy in the event of prolonged dust storms. Transportation within the city relied on pressurized electric rovers. Outside the dome, autonomous drones maintained solar panels and external infrastructure. A small group of people in the audience exchanged wide-eyed glances. They knew they were looking at something that could redefine civilization itself. Musk paused, allowing the weight of the vision to settle in. He spoke of the psychological challenges of living on Mars. Recreation centers, virtual reality chambers, and communal gathering spaces were essential for mental health. Children's laughter, he said, would one day echo inside the domes. The city was designed not just for survival, but for living. Entertainment venues, libraries, and art studios were integrated into the plans. The layout allowed every resident to see the Martian landscape without stepping outside. Transparent panels, coated to block harmful radiation, lined parts of the dome's walls. Residents could watch sunsets where the sky turned a pale, ghostly blue. Musk's voice softened when he spoke about the first settlers. They would be pioneers, living in a place no human had ever called home. Every risk they took would pave the way for future generations. The city's communication systems were engineered to connect with Earth despite the 20-minute delay. Artificial intelligence would assist in real-time decision-making for emergencies. Robotics would handle dangerous external repairs and exploration missions. Musk described the modular assembly process in detail. Each section of the city could be built on Earth, tested, and then shipped to Mars. The Starship fleet would deliver the modules in a carefully timed sequence. First, the life support hub would be installed. Next, the main habitat dome would be inflated and sealed. Then, power systems, agriculture modules, and communal spaces would be connected. This phased approach allowed for gradual expansion without overwhelming resources. A murmur ran through the crowd as the plan's feasibility sank in. The screen shifted to show the first prototype under construction on Earth. It stood on a barren stretch of desert, mimicking Mars conditions. Engineers in protective suits moved around the structure, making final adjustments. Robotic arms assembled the frame with precise, fluid motions. Nearby, a greenhouse module glowed faintly under artificial sunlight. Musk explained that the desert site was a stress test for all systems. Extreme temperatures, high winds, and dust storms were simulated daily. Sensors monitored every detail, from air pressure to structural integrity. The prototype would run continuously for a year before being deemed Mars-ready. This was not just a dream, it was a blueprint in motion. The prototype's control center hummed with the constant whir of servers and monitoring equipment. Technicians sat before wide panels, tracking every data point streaming from the test habitat. Outside the sealed walls, the artificial desert wind howled across the barren expanse. Inside, oxygen levels, humidity, and temperature remained perfectly stable. Musk's team had engineered the habitat's environmental systems with triple redundancy. A failure in one subsystem would trigger an automatic backup within seconds. The power grid, a combination of solar arrays and a small nuclear reactor, operated seamlessly. Energy storage banks beneath the habitat provided power for weeks without sunlight. This design accounted for the infamous Martian dust storms that could block sunlight for months. Hydroponic farms in the prototype produced rows of vibrant lettuce, tomatoes, and herbs. LED grow lights cast a soft pink glow over the plants. Every drop of water was recycled through a closed-loop system. Wastewater from habitation areas passed through purification units before returning to the farms. Nothing was wasted, every resource was accounted for. Even human waste was processed into usable fertilizer for crops. The habitat's kitchen module tested recipes made entirely from in-situ resources. Meals were rich in nutrients but simple in presentation. Fresh salads and protein-packed plant-based dishes were served to the small on-site crew. Crew members rotated between operating systems, tending crops, and performing maintenance checks. One wall of the living quarters displayed a simulated Martian landscape. The projection shifted with the time of day to replicate natural light cycles. This feature was crucial for maintaining circadian rhythms in an environment without Earth's sunlight patterns. Psychologists monitored the crew remotely, looking for signs of stress or isolation. Weekly group activities were scheduled to encourage social bonding. The prototype's communal lounge featured books, games, and a small virtual reality station. In VR, the crew could walk along a simulated beach or through a forest. Such escapes were essential to mental well-being during extended stays indoors. Musk watched test footage with intense focus. He pointed out small inefficiencies for engineers to address. In one clip, a crew member took longer than expected to swap out an air filter. In another, the greenhouse temperature fluctuated by 2 degrees too much. No flaw, however minor, escaped Musk's attention. He understood that on Mars, even the smallest oversight could be fatal. The on-site engineers took notes quickly, implementing fixes within hours. Meanwhile, outside the desert test site, construction crews worked on additional modules. Some were designed for science labs, others for manufacturing facilities. Musk's vision extended far beyond simple habitation. The city would eventually produce its own tools, spare parts, and even spacecraft components. This self-sufficiency was critical for survival. Shipping supplies from Earth would be costly and limited. A true Mars city would need to rely on its own industry. One of the new modules under construction was a metallurgy lab. Here, regolith simulants were being processed to extract usable metals. Another module tested 3D printing with Martian soil substitutes. These printers could produce housing panels, furniture, and even vehicle parts. In the prototype, every system was designed for scalability. If it worked for 10 people, it could be scaled for 100, then 1,000. Every test was documented in excruciating detail. Engineers uploaded gigabytes of data each night for analysis. In the control center, large digital maps tracked the location and status of every component. Red indicators marked areas needing attention, while green meant optimal performance. The crew operated under strict schedules. Every task was timed to measure efficiency. Meal times, work hours, and recreation periods were all logged. The prototype's calendar ran on Mars time, not Earth time. This allowed the crew to adapt to the planet's slightly longer day cycle. Musk believed this adjustment was vital before anyone set foot on Mars. The desert site also tested emergency drills. In one scenario, a simulated meteor strike breached an outer wall. Alarms blared as the crew rushed to seal the affected section. Within minutes, the breach was contained, and life support levels returned to normal. The drill was repeated with different failure points until responses became second nature. Musk insisted that the crew treat every drill as if it were real. He knew that someday, one of them might be. Night fell over the desert test site, and the habitat's lights glowed softly under the dark sky. The surrounding silence was broken only by the low hum of ventilation systems. Inside, the crew moved through their evening routines with practiced precision. Dinner was a shared event, with everyone gathered around a single long table. Laughter occasionally punctuated the hum of conversation. Even in a simulated Mars environment, human connection remained a powerful necessity. After dinner, the crew dispersed to personal quarters or the communal lounge. Some read books from the small but carefully curated library. Others logged into virtual meetings with psychologists and mission planners. Video calls with family back on Earth were rare due to communication delays. Instead, most messages were sent as recorded videos to be played later. This asynchronous form of connection was something future settlers would have to accept. Musk monitored the evening activities from a control room screen. He paid close attention to subtle signs of fatigue or tension. His philosophy was that technology could be perfected, but the human element was the greatest variable. Mars would test not only machines, but also minds and relationships. Late into the night, engineers outside worked under floodlights. They were assembling a new hydroponics module to double the habitat's food production. Pipes, wires, and lighting systems were carefully fitted into place. The module would connect directly to the main dome through an airlock tunnel. This expansion mirrored what would happen on Mars as the city grew. Musk had insisted on practicing modular integration repeatedly before the first launch. In the desert, such exercises were inconvenient but safe. On Mars, mistakes during integration could be catastrophic. The next morning, the crew began their day with health checks. Every vital sign was logged, and daily fitness exercises were mandatory. A small gym area contained resistance bands, stationary bikes, and compact treadmills. Maintaining muscle and bone strength was critical in reduced gravity environments. Though the desert test site had Earth gravity, the routines prepared them for future adaptation. The day's schedule included a simulated dust storm drill. Large industrial fans outside the dome roared to life. Clouds of fine red dust were blasted across the habitat's exterior. Visibility dropped to near zero in minutes. Inside, crew members switched to emergency lighting and sealed internal sections. External drones were sent to check the integrity of solar arrays. Sensors detected dust accumulation, prompting cleaning procedures. Robotic arms equipped with brushes and air jets swept the panels clear. The entire operation was timed to gauge response efficiency. By midday, the storm simulation ended, and normal operations resumed. Musk reviewed the performance logs with satisfaction. Every minute shaved off emergency response times meant lives saved in the real mission. The afternoon was dedicated to resource recycling tests. Water samples were taken from the closed-loop system and analyzed. Purity levels remained within the required thresholds. Waste management units processed organic matter into compost for the greenhouses. Nothing in the system was ever discarded, only transformed. In a nearby lab module, engineers worked on atmospheric processing equipment. These machines extracted oxygen from simulated Martian CO2-rich air. The system was designed to operate continuously without human intervention. Musk described it as the lungs of the city. Without it, no amount of technology or ingenuity could sustain life. The crew rotated through lab duties to understand every system intimately. Cross-training ensured that no critical knowledge was concentrated in a single person. This redundancy in skills mirrored the redundancy in hardware. As the sun set again, the prototype's dome reflected the fading light. The quiet determination of the team was evident in every task completed. Musk stood at the edge of the test site, gazing at the glowing habitat. It was more than a structure. It was the seed of another world. The following day began with an important systems integration test. A newly completed greenhouse module was ready to be connected to the main habitat. The crew suited up in pressurized work gear to simulate Martian conditions. Each step of the connection process was carried out with slow, deliberate precision. A flexible tunnel was extended from the habitat's docking port to the greenhouse airlock. Mechanical clamps locked into place with a satisfying metallic click. Once the physical connection was secured, engineers initiated the atmospheric equalization process. Sensors tracked oxygen and pressure levels as the greenhouse environment matched the habitats. When the airlock doors finally opened, a wave of warm, humid air drifted in. Inside, rows of seed trays awaited planting. Specialized growth racks lined the walls, each equipped with LED panels and nutrient delivery systems. The crew planted fast-growing greens first to establish the initial crop cycle. Musk watched the live feed and smiled faintly. The greenhouse was more than a food source, it was a reminder of Earth. Green leaves and the scent of soil would be priceless in a barren, red world. In a separate lab, engineers ran trials on regolith processing machines. They fed Mars soil simulant into the extractor, which separated fine dust from usable minerals. Iron, aluminum, and silica were collected for future manufacturing tests. This technology would be the backbone of local construction efforts. Instead of relying on Earth shipments, settlers could build directly from Martian materials. Later that afternoon, the crew prepared for a long-duration power cutoff simulation. The habitat's solar arrays were deliberately taken offline. Only the compact nuclear reactor continued to supply energy. Critical systems were rerouted to emergency power channels. Non-essential lighting dimmed, and some modules went temporarily offline. The crew adapted quickly, maintaining food production and environmental stability. These drills reinforced confidence that the city could survive extended blackouts. Musk reviewed the simulation results, noting areas for energy conservation improvements. Meanwhile, in the prototype's workshop, a 3D printer worked on producing a replacement rover wheel. The wheel was made entirely from materials processed at the site. Once complete, it was fitted onto a small electric rover used for external inspections. The successful test meant fewer replacement parts would need to be brought from Earth. In the communal lounge, a crew member recorded a message for their family. The video showed them holding a fresh sprig of basil from the greenhouse. They spoke about the importance of small comforts in an isolated environment. Psychologists later noted that these updates were vital for morale on both sides. As evening fell, the crew gathered to watch a simulated Martian sunset in the projection room. The sky shifted from dusty gold to pale blue as the sun dipped below the horizon. Musk's voice came through the intercom, reminding them that one day they would see it for real. The room was silent for a moment as each person imagined that future. That night, external drones patrolled the perimeter of the prototype site. They scanned for structural weaknesses and signs of environmental wear. The data they collected would inform design adjustments for the actual Mars deployment. The test habitats logs showed nearly flawless operation over the past week. Musk considered this a small but significant victory in a long campaign. He knew the real challenge would begin once the first modules touched down on Mars.